Age-related macular degeneration, or AMD, is a chronic and progressive eye condition with advancing central vision loss. It is known as the leading cause of vision loss for people above the age of 50 in industrialized countries. AMD is classified into dry AMD and wet. One of the first symptoms of dry AMD is a small central scotoma. Images seem to have gaps and written text appears as if letters dropped out. With early dry AMD, objects in the central vision may look dim and colors appear faded. It develops slowly with mild vision loss. With advanced dry AMD, patients have a larger scotoma in the central vision field. Concerned patients have difficulties regarding reading and face recognition. First symptoms of wet AMD are sudden dramatic reductions in central vision. Central vision appears wavy, distorted, blurry, or cloudy. The vision loss in wet AMD advances rapidly and likely leads to a central scotoma and even complete blindness. Patients with central vision loss, such as AMD patients, often have difficulties in recognizing faces and facial expressions in movies, and have therefore trouble following the storyline. They rely on peripheral vision for identifying faces. We present two real-time video enhancement techniques to overcome this problem: blended filtering and constrained scaling. Both can be combined in order to compensate for reduced contrast sensitivity, decreased visual acuity, and a scotoma in central vision. AMD subjects have reduced contrast vision. The filtering method applies an adaptive contrast enhancement filter to compensate for the loss of contrast sensitivity. People with AMD prefer different filtering parameterization for background and face regions. Each video frame is segmented into facial and non-facial regions. Face regions are spatially extended in order to include chin and forehead. An alpha blending mask is used to dissolve face and background filtered regions seamlessly. Our scaling method magnifies face regions temporarily to support the recognition in the periphery. During magnification, the video playback is continued in face and non-face regions. Thereby, filtering is applied simultaneously. Each face is magnified only once during the same shot of a video sequence. If multiple faces are visible during the same shot, several conflicts have to be resolved. First, multiple faces can be magnified simultaneously if the required magnification scale can be ensured without causing overlaps within the limited screen space. Second, if multiple faces need to be magnified sequentially because the screen space is not sufficiently large for simultaneous scaling, an appropriate magnification order needs to be determined. Resolving these conflicts is not an easy task since faces can arbitrarily appear, disappear, and reappear within the same shot. Our algorithm detects these conflicts during runtime and determines the optimal placement and magnification order of faces. Our video enhancement techniques compensate for vision loss due to AMD. We make four novel contributions. First, our methods are based on face tracking technology that provides a good indication of regions of interest in video footage. Second, our blended filtering method enables filtering face and non-face regions differently and to blend both results seamlessly. Third, our constrained scaling method allows scaling multiple faces consistently based on the actual video content and on perception constraints. Fourth, both methods and their combination are real-time capable. We evaluated the efficiency of our methods in the course of a user study with 39 AMD patients at the Medical University of Vienna. The results of our user study show that two groups of AMD subjects appear to benefit from constrained scaling in combination with blended filtering: subjects with advanced wet AMD and subjects with early dry AMD. We believe that size and position of the developed central scotoma could be the main reason for this. Scaling seems to be preferred by subjects with a small to medium scotoma in the central vision. The evaluation also shows a clear preference of blended filtering and scaling in combination. This is reasonable since AMD leads to a loss in contrast sensitivity and visual acuity in all stages. Furthermore, those with severe central vision loss rely on peripheral vision and therefore require both enhancement of contrast and magnification.